Okay, welcome back. Today we're going to talk about solving power equations. Keep in mind the difference between a power equation and an exponential equation is that the variable is in the base in a power equation. That makes all the difference in the world. You've actually been solving power equations all along. We just don't call them that. That's all. Let me give you an example here. So this would be a power equation. It's a quadratic. We've been solving quadratics. We have several strategies now for that. The idea here is, though, the exponent is known. And because the variable's in the base, and I know the exponent, I can solve this through inverses. Keep in mind, the inverse of taking something to a power of 2 is taking the square root. So what we want to do is isolate this base and its exponent. We're going to divide both sides by 2. That'll give us x squared equals 4. And then when I square root both sides, I will end up with x equals positive or negative 2. Alright, so we're going to have those two answers. This isn't really anything new, but they can get more complicated, so I want to look at some of those. Here's an example of another power equation. You'll notice that the base has become binomial. Don't let that mess you up. It's fine. This is still the base, and this is my power of 2. So in order to solve this, I'm going to simply take the square root of both sides. And when I do that, we know that those take each other out. They're inverses, and so they cancel. What that's going to give me now is x plus 2 equal to, now keep in mind the square root of 25 is positive and negative 5. Technically, there's two answers here. And so what that means is that quite possibly 2x plus 1 might turn out to be positive 5, or 2x plus 1 might turn out to be negative 5. When I solve the one on the left, I'll get 2x equal to 4, because when I subtract 1 from both sides, I get 4. Divide by 2, I get x to be equal to 2. Over here, when I subtract 1 from both sides, I get 2x is equal to negative 6. And when I divide by 2, I get x to be negative 3. There's two answers here that work. If I check these, when I plug 2 into my original, which is 2x plus 1 squared equals 25, that's my original. When I substitute 2 in, I will get 2 times 2 plus 1 quantity squared, which is going to give me 4 plus 1 is 5 squared, and that is definitely 25, and that checks. Okay, and when I put in negative 3, I'll get 2 times negative 3 plus 1 and square it. And I want to know if that's equal to 25. And of course, this is negative 6 plus 1 squared, which is negative 5 squared, which is 25, and that checks. Okay. Now again, nobody's asking you to do formal checks on these, but just keep in mind that you want to make sure that they're both valid answers. Many, many times when you're solving these equations, they will ask for just the principal or the positive answer. But you need to be aware when you square root something like this, you got that plus and minus. So we're going to keep that in mind as we do these. So this one's a little different because it has a fractional or a rational exponent. Keep in mind when we looked at these rules, if you remember, when you have a rational exponent, the denominator is the root and the numerator is the power. So this is x to the first power, which is really just x, square rooted. So ultimately, x to the 1/2 equals 3 is the same as saying square root of x equals 3. These are the same exact equation, just a different way of writing it. We need to get used to seeing these fractional exponents, especially as we get into logs. But these are the same, and you can handle them the same way. So over here, if I'm going to get rid of this square root by squaring both sides, I'm going to do the same thing here. Because remember, when you take a power to a power, you multiply the exponents. And ultimately, what I want to do is be able to turn this into x equals. That means x to the first. So how do I get rid of a fractional exponent? If I multiply by its reciprocal, I'll end up getting 1. Anytime you multiply a number by its reciprocal, and you can think of it as 2 over 1 if you like, you're always going to get an answer of 1. So I would take this equation here, and I would, well, let me rewrite this just because it's getting a little sloppy. X to the 1/2 equals 3. What I would do is raise this side to the second power and raise this side to the second power. Just like over here, I would raise this to the second power and this to the second power. And if you want to rewrite it like this, you are absolutely welcome to do that. It's not necessary. But certainly if it helps clarify things and helps with your understanding, then that's what I would recommend. Remember, when you take a power to a power, you multiply these, and 1/2 times 2 is 1. So you will end up with x equals 9. And that is your answer. Okay. Now that idea needs to be explored a little deeper. So here's an example that looks pretty involved, and it is, but again, we know inverses. And so because this variable here is in the base, and this is the whole base, and this is raised to the negative 1/2, I'm going to use my inverses, my powers, to break this down to find x. First thing I'm going to do is isolate this base and its exponent. So I'm going to get rid of this minus 1 by adding 1 to both sides. And when I do that, I'll have a 9. So I'll have 3 times this base raised to the negative 1/2 equals 9. Next thing I want to do is get rid of this 3. So I'm going to divide both sides by 3. And then that's gone. That leaves me with x plus 1 to the negative 1/2 equals 3. Now again, the idea is to eliminate this. And the negative is a reciprocal. It means 1 over. The 1/2 is a square root. And so, you know, if you want to, you could rewrite this piece here as 1 over the square root of x plus 3 equals 3 over 1 and cross multiply and keep going. But that's a lot. That's a lot to do. So even though this is very valid and nobody's going to ever say, oh, no, that's not good math, it is good math. But the other thing we can do is simply raise each side, because remember, in an equation, whatever you do to the left, you got to do to the right. I'm going to raise each side to the reciprocal of negative 1/2. One of the most common mistakes made is that when you take the reciprocal, you negate it. You do not. Keep in mind, a number and its reciprocal have to give you 1. So if the number is negative 1/2, its reciprocal is negative 2. I'm going to raise each of these to the negative 2. And now when I multiply the negative 1/2 times the negative 2, that will give me a positive 1. 3 to the negative 2 is 1 over 3 squared, which is 1/9. Last step, subtract the 1 from both sides, and I'll get x equals, if I take 1/9 minus 1, I will end up with negative 8/9. Answer. I'm going to show you one more example here, and then I'm going to give you a couple to try on your own to see if you've got this concept down. So again, my base is my x raised to the 2/3 power. First thing I want to do is isolate this power, the base and its exponent. So I'm going to divide both sides by 3, and that will do that for me. So I'm going to get x to the 2/3 is equal to 48 divided by 3 is 16. Now I'm going to raise each side to the reciprocal power. And so I will raise the left to the 3/2 and the right to the 3/2. So 2/3 times 3/2, of course, is 1, x to the first. 16 to the 3/2, you can use your calculator to do this. Your calculator will calculate that for you. Or you can know that this means the square root of 16, which is 4, cubed, which happens to be 64. Okay. As a radical, 16 to the 3/2 means the square root of 16 cubed. Once again, this is the root. This is the power. We talked about that the other day. Well, it was actually before the January break. Okay, I'm going to put one up to see if you can do it. So here's your problem. 4x to the negative 1/3 equals 8. I want you to copy it down and then pause. Go ahead and see if you can peel back the layers. You want to isolate this power and then see if you can get the final answer. When you start it up again, the answer will be there for you. Okay, so your one, hopefully you got that. Isolate, divide by 4, raise each to the -3 power to eliminate that exponent of -1/3. It's the inverse. And when you take 2 to the -1/3, you get 1/8. If you got that one, go on to the next one. So here's an example for you to try. It's a little bit more involved. Just be careful. Make sure you do your inverses. It's 2x plus 3. I'm sorry, 2x plus 1 is your base. Raised to the 4/3 minus 6 equals 75. Go ahead and get that copied down. And when you hit pause, you can work it out. When you hit play again, the solution will be there for you, that you can see if you did it right. Okay, hopefully you got an answer at 13. If you didn't, you want to take a look back step by step to see what it is possibly you may have gone, or where you may have gone wrong. If you still don't understand, then bring your questions into class tomorrow. We will be looking at more of these types of problems, and that's all for now. Okay, have a good night.